Okay, 5.5 is function operations. So we've been working with radical functions. Okay, we kind of move into, in the second half of this chapter, a more general function concept here. So specifically in 5.5, it's function operations. So adding, subtracting, multiplying, dividing functions, and then whatever we'll obviously finish stuff tomorrow, but then talking about function composition, okay, which is talking about Fogg and Goff, if those words sound familiar to you, but we'll talk about that later. So adding and subtracting functions, okay, don't overthink this one, okay. So as we look at example 8, okay, we're given f of x, which is defined to be 3x plus 4. We're given g of x, which is defined to be x squared minus 5x plus 2. The directions ask us to perform each function operation and then find the domain. Okay, so first part asks us to find f of x plus g of x. Don't make it any harder than it is. F of x plus g of x. What are we going to do? What is f of x? 3x plus 4. What is g of x? It's the x squared minus 5x plus 2. And what are we being asked to do? We're being asked to add them. What do we need to do here to finish this piece up? Okay, add those like terms. Okay, as we talk about like terms, my brain tends to start with highest powers and work my way down. If you just want to go in order from left to right, that works too. What do we have in the way of x squareds? We just have an x squared. What do we have in the way of x terms? And 3x minus 5x is minus 2x. And then in terms of constants, we have 4 plus 2, which is plus 6. Okay, guys, if they ask you to do something as basic as just add f of x plus g of x, look for like terms, put them together. Okay? So x squared minus 2x plus 6. Now, before we move on, they also asked for something else, though, didn't they? They asked us to identify the domain. If you haven't noticed in Algebra 2, they like to talk about domain and range a lot. Okay? Yes?
Do we not factor?
No. We're just being asked to find what is f of x plus g of x. I don't think it does factor, actually. So, but no, you're just combine like terms. Don't overdo it. Okay, so domain is, are there any values of x that can't go in here? Domain is going to be every value of x that can go in this problem. Okay, that could work. Are there any values of x that we couldn't put in here? And the hint is, okay, if we had fractions, you can't let your denominator equal what? 0. If you have a square root, you can't let the underneath piece of the square root be a negative if we want to stay in real numbers. But in terms of plugging values into 3x plus 4 and x squared minus 5x plus 2, or in other words, plugging values into here, are there any values I can't put in? Are there any reasons? You can put in any value you want here. We don't have a fraction to worry about, where a denominator, we can't let the denominator be 0. We don't have a square root, or we don't want the square root to be negative. In this, I'm going to call these polynomials, okay, where you just have terms being added and subtracted. Any term's going to work, or any number's going to work. So if I say any number is going to work, what kind of domain am I talking about here? Yeah. I'm going to use the phrase all real numbers. Obviously, that could be negative infinity to positive infinity. Okay, second part. What changes up here? It's subtraction. So if I write this out, it's f of x, which is 3x plus 4, and then it's minus g of x. When I am subtracting g of x, I want to make sure I'm subtracting the whole thing. So I'm going to put it in parentheses. And we are subtracting the quantity x squared minus 5x plus 2. Okay? So, slight changes in that. What does that subtraction sign mean I'm doing? Basically changing the signs, right? So if you want to, you can write it out as this is still 3x plus 4, but this is going to be minus x squared. Minus 5x is going to become plus 5x, and plus 2 is going to become minus 2. Okay? You don't necessarily have to write that step out. You can do it without that step, by all means. But just realize you're subtracting everything in that second piece. So, what changes? What do we have in the way of x squareds? Just x squared, but it is a negative x squared. Okay, it's in the subtraction group. We're subtracting it from nothing. So 0 minus x squared is negative x squared. X terms, 8x, it's 3x. And you can think minus negative 5x, which is 3x plus 5x, which is plus 8x. And then becomes 4 minus 2, which is plus 2. So when you subtract, it cleans up to be negative 8x squared plus 8x plus 2. Again, I want to address the domain. Okay. Thoughts on domain? Still all real numbers? Are there any numbers I can't put in? No, I don't have fractions happening. I don't have radicals happening. I don't have anything that's not going to allow certain values. So it is still all real numbers. Okay. And guys, anytime it's just these polynomials, unless you're dividing them, it's going to be all real numbers pretty much every time. Okay. Okay. Let's practice with b real quick. I'll be honest, I'm not sure how much we need to practice, but f of x is 2x squared plus 7x minus 1. G of x is 3 minus 2x. Perform each function operation and find the domain. So, A, first part asks us to find f plus g. So, 2x squared plus 7x minus 1, and then plus 3 minus 2x. Put your like terms together. What do you get? Two x squared plus 5x plus 2. We only have a single x squared term again, so it just carries down. 7x goes with minus 2x, which is 5x. Minus 1 goes with 3, which is 2. Domain. Any exceptions this time? No, you're still just adding and subtracting two polynomials. No denominators to worry about. So again, we're going to say all real numbers.
F plus g takes, does that change anything set up?
It does not. It does not. I kind of forgot that it was set up differently. So up on the first one, it said f of x plus g of x. This one, it's f plus g of x. That's just a different way to say the same thing, basically. Okay, so good question there. In my mind, I kind of forget that it looks different, but it's no different.
I mean, really, it's just undistributed.
Kind of, yeah. I mean, I don't think of this as being a distributed thing, but that is exactly what this looks like, is that if you take that x and distribute, it's f of x plus g of x. So honestly, just different notation. And I don't remember what you see in Sabas, but I'm guessing you will see both notations in Sabas. So, okay, what about B? G minus f of x means we're doing, well, keep it in this order though. G of x minus f of x. Does it matter that they flip the order on us?
Yeah.
It does. Okay, so beware. So I'm going to write, if it was adding, it wouldn't matter though. But subtracting matters. So G minus f means we're doing 3 minus 2x, and then minus f, so minus the quantity, 2x squared plus 7x minus 1. Okay? I'm seeing erasings and whiteouts. Read carefully is what I always say. And will Sabas do this to you and flip them around? Oh, yes, definitely. So if I distribute that minus sign, you don't have to. You can just jump right to the answer if you want. It's 3 minus 2x, and it's going to be minus 2x squared minus 7x minus negative 1, which is plus 1. Okay. So what do we have? We got the negative 2x squared minus 2x, and minus 7x is going to be minus 9x, and 3 plus 1 is plus 4. And what about the domain? All real numbers. Okay. Adding and subtracting. Keep it basic. Look for like terms. Watch out for subtraction. Okay. Watch out for which order they put it in. Okay. We're going to talk about multiplying fractions now. Multiplying fractions. You guys already know how to multiply basic pieces like this. Okay. So that's not going to be too much of an issue, but we've got a word problem situation thrown in. And one piece I want to point out is we're going to talk about revenue. That didn't work. And revenue is equal to price times demand. Do we know what revenue is?
Like how much it costs and how much somebody wants it. So if the price is like $300, but you really want it, so you times by 3.
Okay, he's giving me specifics here, but yeah. So revenue, it's the money you're bringing in, right? It's the money you are making. Now, when I say it's the money you're bringing in, it's different from profit. Okay, profit is what you're making after you cover all of your costs. Revenue is just what you're bringing in here. Okay, so let's look at example A. The demand D in units sold for a company's new brand of cell phone at price X in dollars is given as D of X equals 5,000 minus 10X. What is the company's expected revenue from cell phone sales in terms of the price X? Then state the domain of this function. And then, if the price is $200, how much revenue will the company earn? Okay, did you follow all that? Demand is D, okay, for a company's new brand of cell phone, price X. So they're explaining what some of these pieces are. So D stands for the demand, X stands for the price, okay, and so the cell phone price is X. They give us a function for demand, yes. D of X is 5,000 minus 10X. What is the company's expected revenue from cell phone sales in terms of the price X? So I'm going to stop there. We'll worry about the rest of the questions later. Okay, we've got like 3 questions happening at once here. revenue. How do we find the company's expected revenue? Okay, price times demand. What's the price? Nope, we haven't read that part of this question yet. We're right now, what is the company's expected revenue in terms of price X? So the demand, D of X, is 5,000 minus 10X. That's the demand. What's the price? What do we use for the price? I'm not looking for a number here.
X.
X, yes? Okay. They talked about cell phone is priced X. It's just that generic X because we're asking revenue in terms of X. Now, I'm going to call revenue R. Okay. Typical revenue, price times demand. We just said the price was X times what's the demand? Demand is that D of X, which is 5,000 minus 10X. This is where the multiplying is old news. How do we multiply here?
Distribute.
Distribute, yes? Okay. So we've got R of X is what I'm just going to call it. You're distributing the X. So when you multiply both pieces by X, I'm going to have 5,000X minus 10X squared. That's the answer to the first question there. What is the revenue in terms of price X? Okay.
Don't have to find X.
Then what?
Then don't have to find X.
We don't have to find X, no. If you want to jump to the next part, well, okay, we have to talk about domain at some point, yes? You want to skip domain for a moment and go to the last part?
Yeah.
If the price, well, don't let me forget to come back to domain. Okay, if the price is $200, so right here, if the price is $200, how much revenue will the company earn? How am I going to do that?
200 for X.
Okay, now's when you get to use the 200. Realize these could each be, and I don't remember how Savas is set up, but these could each be different parts in a question. Okay, if they want the function, they're going to want what I have already circled. If they want the price, the revenue when price is 200, we're finding R of 200, which means every place there's an X, you put in 200. So 5,000 times 200 minus 10 times 200 squared. There's a bunch of zeros happening there. I got that much. You can grab the calculators or you can do it by hand. Let's see. So that first piece is 1 million. Is it 1 million minus 400,000, I think, which is 600,000? Is that working out?
Cool.
I did a crazy thing. I did that without a calculator, guys. I know it's a crazy thought, but it is doable.
Your last part. I gotta use my resources.
I can use my resources too, which is, hey, Patrick, what'd you get on the calculator there? You know. But, okay, $600,000. I just went with 5,000 times 200. Well, 5 times 2 is 10, plus 1, 2, 3, 4, 5 zeros. There's my 1 million. Then I did 200 squared, so that's 2 times 2 is 4, and then 1, 2, 3, 4 zeros times 10. So 4 times 1 is 4, and then 1, 2, 3, 4, 5 zeros. Put my commas in so it made sense. It's doable. I know you guys don't like to take the time to do it, but it's doable. Okay. So that answers if the price is 200, what is the revenue the company will earn? What have I not talked about yet? Domain. Okay. So as we talk about domain, domain is in regards to X, yes? So we're basically asking, what does that X have to be? Okay, what is it allowed to be? So start with the basics. X has to be anything, has to be positive, yes? Okay, we have to factor in the demand here. But to start with, X is price, and we know that price is going to have to be something greater than or equal to 0. Actually, should I even say equal to? I don't even know if I should have that equal to in there. Yeah, so it probably should just be greater than. But I guess there is that weird thing that, I don't know. I'm going to leave it for right now. Now, let's talk about price. Let's talk about demand. Can't spell here. Jeez. Okay. Your price has to be positive. It has to be bigger than 0, yes? What's your demand have to be? It's going to also have to be, think in the same terms, greater than 0. You're going to have a positive demand for this to work. Okay? Otherwise, we can't even talk about this problem really. Okay? So you're going to have a positive demand. If we think about that, what was our demand? Our demand was 5,000 minus 10x. If it has to be positive as well, what am I saying? It has to be greater than or equal to 0. Okay? With that in mind, solve this, because this is going to end up giving us our upper limit. Okay, so if I solve this, 5,000 minus 10x greater than or equal to 0, how do you want to solve for x? Can you guys handle that? Why would we add 10x? So x becomes positive. There's 2 different ways we can do this. I'll talk about both. I know some of you are like, ugh, I don't like moving that x to the right. It works though. So we have 5,000 greater than or equal to 10x. And then what do you have to do to solve for x? Divide by 10. 5,000 divided by 10. What happens if I say strike a 0 out? Does that sound like something you learned in elementary? So 5,000 divided by 10 is 500 greater than or equal to x. Or our brains probably think better the other way. Reverse that statement. Instead of 500 greater than or equal to x, what's the other way to say that? X less than or equal to 500. So, in order for this demand to stay positive, our amount of phones, our price has to stay under 500. Okay? Because if that price, keep in mind, if the price is too low, it's going to sell quickly, right? If that price is too high, it's not going to sell. Okay? And so here when we talk about our domain, it has to be greater than 0, but less than 500. So I'm going to write this as 0 less than or equal to x less than or equal to 500. Okay, so it's kind of looking at the constraints that price has to be positive, demand has to be positive. If the demand is negative, you're not going to sell anything. I don't even know if negative demand exists, but you get the idea there. Okay, so a little bit more thinking on the domain when we start talking about revenue. Okay, it's a little bit more just because we have to factor in the domain issue there. Okay, Now, if you look at B, there's not quite as much into B. Okay? So look at B real quick. Suppose demand D for a company's product at cost X is predicted by this function D of X. And the price P that the company can charge for the product is given by P of X. Find the company's revenue. How are we going to find revenue?
Price times demand.
Price times demand. You have a price function and a demand function, yes? Oh, are we going to have to do some math? Yeah. In order to find R of X, basically you want to do D of X times P of X, which means, what did we say D of X was? It's the negative 2500ths X squared plus 1,000 times P of X, which is X plus 16. Okay. Why don't we multiply that real quick? I was going to have you guys do it, but we'll multiply real quick and be done with this. Negative 2500ths X squared times X. What do you get? Okay, negative 2500ths X cubed. What about negative 2500ths X squared times 16? Okay, negative 4X squared. It's binomial times binomial. We're foiling, right? Ooh, okay, you guys can all do this one. 1,000 times X. 1,000X. 1,000 times 16. 1 times 16 with adding on 3 zeros, so 16,000. Clean it up.
Can be divided by 0.25.
They could be, but that would just be factoring out a GCF. We're going to leave it as is. We're going to leave R of X right there for our revenue function. Okay.
Take that out though.
No, well, you can't divide it out altogether. It would still have to be there as a GCF. You can't divide it out altogether. You're changing the expression. So my guess would be you just leave it like this. Okay? Okay. Backtrack and get 5-4 done. Okay? You've got to get 5-4 done. I can't help you answer questions or help you get unstuck if 5-4 is not done. Okay? Get that 5-4 done. You can start looking at 5-5, but we'll pick up and finish notes tomorrow.